Check it out, YouTube. I cut out enough for 3 butt joints and 3 lap joints all set up over here, and this is going to be pretty fun. Just went at it with the plasma cutter, turned it down as low as it'd go, and it still kept on just shooting right through this. So it's, you know, you can tell it's some really thin material. So anyway, yeah, now we just have to get the welder all nice and set up. Now before we set up the welder, I'd just like to take a minute here to say a couple words about my specific machine and about MIG welding this thin stuff in general. Now the welder we're going to be using tonight is a Hobart Handler 187. It is an absolutely wonderful machine. It's a 220 volt MIG welder, which gives it enough power to easily do 1/4 inch, but that's about where it maxes out. Or you can dial it back down, do really thin stuff like this. Now, I will say that 110 MIGs, while they don't have a lot of power, they are pretty much made for auto body work, and you can usually pick them up like on Craigslist or other places cheap like that. And you know, joint prep is absolutely essential. Gaps are not your friend in general, and especially not when you're working with thin material. We got to get these pieces as close up with each other as we possibly can. We're going to do our best to seal up the gaps here before we start welding, because it's really, really easy to burn through on this stuff, and if you have a gap, you're basically just asking for trouble. That being said, this butt joint here does have a gap in it, just because that's the nature of what happens when you cut something. There's a curve. And so I'm going to use that as an opportunity to talk about, you know, how to weld up something like that a little bit later on in this video. Now, wire. You're going to want to run just regular mild steel wire, assuming you're working with mild steel. And for thin material, you want to use thin wire. Just like for thick material, you want to run thick wire. So basically, we're going to be running 30 thousandths inch Lincoln L56 Super Arc. It's wonderful, wonderful stuff. And 23 thousandths or 24 thousandths would be a lot better, but 30 thousandths is definitely acceptable for this kind of stuff. Alright, now there's going to be 2 different types of joints we're going to weld. We're going to weld a butt joint, which is your 2 pieces, just, you know, buttered up against each other. And then there's the lap joint, when one of them basically just overlaps the other. And on a few tips and tricks here, you're going to want to go fast. When you input heat into metal, it obviously heats up, and if it heats up enough, it's going to burn through. Now, this isn't usually that much of an issue with anything like, I don't know, thicker than this, but there's just, with material that's paper thin, there's just nowhere for that heat to go, so it's just going to all run through. So yeah, we're probably going to end up pushing the puddle, maybe pulling the puddle. You'll get a feel for what's going to be best for any specific situation that you find yourself in. A lot of the time with stuff like this, it's basically just welder's preference. And when we get to this butt joint here, we're going to be doing what's known as spot welding or stitch welding, whatever you want to call it. Basically, you pulse the trigger. Little tack, little tack, little tack, little tack. For most things, that's not a good idea, because there's a saying in the welding world that tack, tack, tack equals crack, 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 because well, you know, that's where most cracks start in welds. They start at, you know, the ends. And a tack weld is basically just the end of a weld. And we're going to be stacking these up on top of each other. So for anything structural, it's basically asking for trouble, but for what we're doing here, it'll be just fine. That being said, for things that don't have a gap and have pretty good fit up, you're going to want to run no more than 1 inch at a time and wait for it to cool. Whatever you do, don't put water on the joint. A lot of people do that. And like I said before, since this is such thin material, you're going to want to jump around. So like if I was welding all over this tailgate, I'd weld like 1 inch here, and then 1/2 inch down here, and 1 inch over here, and 3/4 inch down this way. Basically, you don't want to put too much heat into any specific place without giving it time to cool. So basically, just skip around, and that'll cut down on warpage and help you control the heat. Now, you never want to stand in front of a regulator like where I have the camera, just because if this thing exploded, this part, the bonnet, would take off like a rocket and go straight through you. So basically, I'm just going to stand off to the side and crack this valve open here. I'm just going to keep on turning, because this thing seals when it's closed and it seals when it's all the way open. If you only open your tank like halfway, you're basically just leaking air out into the environment. So now I got the trigger here. I'm going to pull this down because that'll get the gas flowing. Now first, I'm just going to crank on this until I see this needle move up just a little bit. There, just like that. Right now it reads 20 cubic feet an hour. That's kind of what we're going for. But if you notice when I pull the trigger, that definitely drags it down. So I've got the wire feed knob on the 187 turned all the way down. Just going to hold down this trigger and adjust the T-screw over here until we're actually at 20 cubic feet an hour. Yeah, and go from there. Here we go. There, we're good. That one's so bad. Now whenever you pull the trigger, bam, 20 cubic feet. That's what we're after. Next step, adjust the welder itself. The Hobart welders, at least the MIG welders, come with this handy dandy door chart, which is a good starting point, but I find that the wire feed speeds are generally a little bit high. So in most cases, I'll back the wire feed down, crank the voltage up another notch, and it's pretty much set. But we're going to stick pretty close to what it wants us to do on this. So let's see. Solid wire, ER70S6, C25 gas mixture, 30 thousandths. Let's see. According to this, won't do 24 gauge, but it will do 20 gauge, yeehaw, and it wants to be set on 1 and 40 for that. So we're just going to come over here, crank this way down, and crank this up from running the gas through it. And actually I'm just going to set it right about there. We should be set. Alright, let's do this. So we now have a good ground, and basically from running that gas through there, we have a few unwanted inches of wire, so I'm just going to come in here, get rid of those, and here we go. Basically, just to keep these various pieces of metal from going to different elevations, I'm just going to tack it in a few places each. Alright, now I'm just going to start in on a little bead here. That's about as far as you can go without it wanting to burn through. Because y'all got to remember, there's definitely a gap in here. See, that one burned through a little bit. Just that little bit of welding caused it to burn out right there. Now y'all should be skipping around more than I am. I've done most of my welding down here. I should have at least this much up here. So, back at it. There, it just burned through again. If it does burn through, the best thing you can do is to just stop and let it cool. And now that this is cool, it shouldn't be that big of a deal to weld on up. Now we'll give that a second to cool as well. Just like that, we fixed our burn through. And one other thing here, whenever you run a lap joint, you don't want to actually try, I guess, to to keep your wire up in here and try to weld everything together that way. What you want to do is run a bead parallel to your upper plate and just let the edge of the puddle envelop, your upper plate. Yeah, this was your crash course in MIG welding thin material. I really hope you guys enjoyed the video. Don't forget to rate, comment, and subscribe for more.